In this demo, we'll perform classification on the same wine dataset that we saw earlier, but this time we'll use the Spark ML libraries instead of the Spark ML lib libraries. That means we'll be working with data frames, not RDDs. We'll also evaluate our classifier using the F1 score. We write our code in the M2 Demo 1 IPython notebook. When we use Spark 2, we use the Spark session to read in the input data. The Spark session is the simplified entry point that is used in Spark 2. It encapsulates within itself the Spark context, the SQL context, and all other contexts that are available with Spark. We use the Spark session to read in the CSV version of our wine dataset. The Spark session allows us to specify the format in which the data exists and also whether it has a header or not. In our dataset, we have no header. The Spark session reads in the input data in the form of a data frame, which is a tabular representation of the underlying data. The columns within this data frame do not have headers, which is why Spark has assigned some column names to them. We'll go ahead and assign meaningful column names to our raw data and store it in the dataset variable. Once we work with data frames which have column names, they are much more intuitive and easier to use. In fact, the use of data frames and the tabular format, along with the presence of column names, make data frames easier to visualize, and it's easier for you to see what's going on at every step in your ML pipeline. Next step is for us to convert these features to feed into our machine learning algorithm. Just like we use a labeled point when we use the spark.mllib library, we are now going to set up our data in a vectorized format that is expected by the spark.ml library. The vectorize function that we've just defined extracts the labels and the features from our input data frame and then converts the features to a dense vector. Here we use the map function of an RDD and we convert the result to another data frame. This data frame has two columns, the label and the features. Once you vectorize your input data set, you'll see that the resultant data frame has two columns. You can call the show method to see this. The first column holds the labels of our training data. The labels represent the cultivator that actually produced that particular wine. There are three cultivators represented by the labels 1, 2, and 3. The second column are the wine features. All of these features are lumped together into a single column. If you examine this vectorized data, you can see that each row in the Spark data frame is a row object with a label and features, which are dense vectors.